In today's lesson, we'll be learning how to factor quadratic expressions of the form x squared plus bx plus c. B and c represent integers. You might be asking yourself, there's a b and there's a c, but where is the a for ABC? Well, the a is secretly hidden in front of the x squared. And in this situation, a is equal to 1. However, we do not write the 1 in. Therefore, all of the techniques that we're learning today correspond to quadratic expressions where the coefficient of the x squared term is 1. Here are the key concepts for today's lesson. You should go over these on your own. In our first example, we want to factor this quadratic expression x squared plus 7x plus 12. Immediately, you'll notice that there is no coefficient in front of the x squared. In fact, the coefficient is 1, but it is never written in. Let's begin by rewriting our question. X squared plus 7x plus 12. If you look at these three terms closely, there is nothing that you can common factor out. Therefore, we must use a different technique. I want you to take a close look at the numbers that are present in this expression. Positive 7 is a coefficient, and positive 12 is a constant. We want to find two numbers when added together equals positive 7. And we want to find two numbers when multiplied together will give me positive 12. You're going to be using your times tables along with some guess and check. I figured out that two numbers add together to give me positive 7 could be positive 3 and positive 4. If I multiply those same two numbers together, that will give me positive 12. Therefore, I can factor this quadratic expression into x plus 3 multiplied by x plus 4. If you wanted to check your answer, you could always use the FOIL technique. In our second example, we want to factor this quadratic expression x squared minus 29x plus 28. You'll notice that there is a coefficient of 1 in front of the x squared. However, it is not written in. Let's begin by rewriting our question. X squared minus 29x plus 28. I want you to take a close look at the numbers that are present within this expression. I have a coefficient of negative 29, and I also have a constant of positive 28. You want to find two numbers when added together will give you negative 29, and the same two numbers when multiplied together will give you positive 28. You'll need to use your times tables as well as some guess and check to figure out these two numbers. I've gone ahead and done that already. Two numbers that add together, which will give you negative 29, are negative 1 and negative 28. If I multiply those same two numbers, I will get positive 28. Therefore, I can factor this quadratic expression to x minus 1 multiplied by x minus 28. And if you wanted to check your answer, you could use the FOIL technique. In our third example, we want to factor this quadratic expression, x squared plus 3x minus 18. You'll notice that the x squared has a coefficient of 1. However, that is not written in. Let's begin by rewriting our question. X squared plus 3x minus 18. I want you to take a close look at the numbers that are present. I have a coefficient of positive 3 over here, and I have a constant of negative 18. Therefore, you need to ask yourself this question. What two numbers, when added together, will give you positive 3, and the same two numbers, when multiplied together, will give you negative 18. At this point, you'll need to use your times tables and some guess and check. I've figured out these numbers to be positive 6 and negative 3. When I multiply those same numbers together, that will give me negative 18. Therefore, when I factor this quadratic expression, it becomes x plus 6 multiplied by x minus 3. Again, you can check your answer by using the FOIL technique. In our fourth example, we want to factor this quadratic expression, 3x squared plus 12x plus 9. Immediately, you'll notice that this question is slightly different from the previous three questions because the coefficient of x squared isn't 1. In this case, it is 3. Therefore, the technique that we've been using previously has to change a little bit. Let's rewrite our question first. 3x squared plus 12x plus 9. Just like before, I want you to take a look at the numbers that are present in this expression. I have a coefficient of 3, I have a coefficient of positive 12, and I have a constant of 9. Ultimately, I want the coefficient of x squared to be 1. That means I need to factor something out. So you need to ask yourself, what is the greatest common factor of 3, 12, and 9? Well, the greatest common factor of 3, 12, and 9 is 3. Therefore, we're going to factor out 3 from all of these terms before we begin. So that becomes 3x squared, that becomes 4x, and that becomes 3. Remember, when we're factoring out something, we need to divide all of the terms by that factor, which happens to be 3 in this case. At this point, you can do the technique that we've been doing in the last three examples. So we're going to take a look at the expression within the brackets. We're going to take a look at the numbers. That is, the coefficient here is positive 4, and the constant here is positive 3. We want to think of two numbers when added together will give me positive 4, and those same two numbers when multiplied together will give me positive 3. You're going to use your times tables and a little bit of guess and check, and you should come up with positive 1 and positive 3. And when you multiply those same two numbers, you should get positive 3. Therefore, I've just factored the expression within the brackets, so that becomes x plus 1 multiplied by x plus 3. And again, you can double check your final answer by using the distributive property or the FOIL technique. In our last example, we want to factor this expression, x to the power of 3 plus 18x to the power of 2 plus 72x. You'll notice that this question looks different from our previous questions. Most specifically, that 3 should be a 2, this 2 should be a 1, and there should be no x beside this 72. Therefore, we probably need to do some common factoring. But let's rewrite our question first. x3 plus 18x to the power of 2 plus 72x. If we're going to common factor, we need to take a look at all the numbers that are present. There's a coefficient of 1 here. There's a coefficient of positive 18. And there's a coefficient of positive 72 here. So you need to ask yourself the question, what is the greatest common factor of 1, 18, and 72? Well, the greatest common factor happens to be 1. So there's nothing we can really do there. But let's take a look at the variables. Are there any variables that are common among all three terms? And that variable happens to be x. And you want to take a look at the exponents of x, and you want to take the lowest exponent, which happens to be 1. At this point, we want to factor out 1 and x to the power of 1. However, I'm going to ignore the ones, and I'm going to end up just factoring out an x. So that becomes x to the power of 2, that becomes 18x, and that becomes 72. Remember, when you're factoring out something, you're really just dividing every single term by that factor. Now we can just use the same technique that we've been using in the last couple questions. Let's take a look at the numbers that are present within the expression in the brackets. I have a coefficient of 18 here, and I have a constant of 72. You need to ask yourself the question, what are two numbers, when added together, will give me positive 18, and those same two numbers, when multiplied together, will give you positive 72. You're going to use your times tables as well as some guess and check, and you should come up with the numbers of positive 6 and positive 12. And when you multiply those same two numbers, you should get positive 72. Therefore, whatever was in the brackets can be factored into x plus 6 and x plus 12. And of course, you can double check your answer by using the distributive property as well as the FOIL technique.